Good morning, this is Dr. Turner for Integrated Math 2. Today we're going to be talking about 4.2, which is solving quadratics. Specifically, we're looking at solving quadratics that don't have a leading coefficient of 1. In 4.1, we looked at 1x squared plus bx plus c and how to solve that. Today we're going to be looking at how to solve other quadratics with a higher leading coefficient. So there's a couple techniques you can do here when you are trying to solve. And it really starts out with just kind of guessing. So let's say we have something like this. So let's say you have something like 2x squared minus 9x minus 18 equals 0. Okay? The first thing you can kind of do before we look at how to do it with the x is you could, in theory, just write it in parentheses. And I know that if I look at 2x squared, which is right here, 2x squared's factors have to go here and here. And there's really only one option for 2x squared. It's 2x times x. And because of the commutative property, it doesn't matter if the 2x is on the left or right. Then what's going to go at the end here is going to be the factors of negative 18. Well, that's a little bit more complicated because we have multiple factors of negative 18. We could have positive 1 and negative 18. We could have negative 1 and positive 18. We could have positive 2 and negative 9, or we could have negative 2 or positive 9. We could have positive 3 and negative 6, or we could have negative 3 and positive 6. And if this was a larger number, I might have 10, 20 different factors. So if you're just sort of guessing, trying to figure out which one it is, then you start out and you plug in some numbers. So 2x, let's say I put negative 1 here and a positive 18 here. Again, I already know, because I looked at the factors, that this is going to add up to 2x squared and this is going to add up to negative 18 when I FOIL this out. However, what I do need to check are the outside and inside terms. Remember, your FOIL is first, outside, inside, last. So we know first and last will already work. So I need to check the outside and the inside, and you're checking to see if they add up to the b term, to the middle term that's left here. So 2 times 18 would give me 36x. Negative 1 times x would give me negative x. And if I add those, it's 35x. That's too high. So that doesn't work. So then I could go in and erase this, erase the 18, erase the negative 1, and then let's try something else. Let's say I go down, I do positive 2 and minus 9. 2 times negative 9 is negative 18, plus 2 times x, that'd be negative 16x. Still too high. Well, maybe we change the signs around. Let's do minus 2 and positive 9. 2 times 9 is 18, negative 2 times x, add those together, that's 16x, still too high, and it's positive, our b term is positive. So let's go down, check another factor. Let's try positive 3 and negative 6. 2 times negative 6 is negative 12, plus 3x, that's negative 9, so that's factored. So it takes a little bit more work if you are just sort of guessing. It's doable, but again, it can take a few extra steps here if you're just guessing. But let's finish this one up now that we've factored it. Remember I said that before you know kind of how to take the shortcut, you should be setting each of these factors equal to 0, because 0 times anything is 0. It doesn't matter if this term is 0 or this term is 0. 0 times anything is 0, so that it would be a solution. So on the right, I simply add 6 on both sides to get x equals 6. On the right, I'm going to subtract 3 on both sides, and then divide by 2. Now, guessing and plugging and chugging, I mean, that is a strategy. However, it's not a very effective one, especially if I had something like, let's say 64 for my C term. that could have up to 32 different factors. So rather than doing that, we're going to use the x. Remember, we said that on the bottom, we're looking for the b term to be a sum here. And on the top, we're looking for a product. Before, when we were looking at a, b, and 1, it was really just c. But now we're looking at products that have something other than 1 for a. So we're looking for a product that is whatever a times c is going to be. Okay, so let's say the problem is 4x squared plus 11x minus 3 equals 0. So following this, I'm looking for two numbers that multiply to get a times c, negative 12, but add up to 11. So I'm looking for two numbers that multiply to get negative 12, but add up to 11. After a little bit of maybe factoring here, we end up with 12 and negative 1. Now, normally that would mean that our solutions are negative 12 and positive 1 if a was 1, but it's not. So what we have to do, rather than just saying x equals negative 12 and x equals positive 1, we actually have to divide them by our a term. So once you find those two numbers, you're going to divide by a. You get x equals negative 3 and x equals 1/4, or 0.25 if the instructor prefers decimals. And that's it. Now, if I asked you to factor this, it takes a little bit of reworking to get it into the correct form. But we're not going to go over that today because really all I'm asking you to do is solve, right? Unit 4 is all about just solving, not necessarily factoring that. Okay, let's look at another example. Let's look at 6x squared minus 11x minus 35 equals 0. Same thing, we're going to make the x. We're doing a times c. Now that's a little bit of higher of a number, and if you need to use calculator at this point, that's fine. But that's going to be 175. It's going to be negative 210, and then my b term is negative 11. Now that takes a little bit more work in terms of figuring out what those factors are, right? You're looking at the factors of 210. After a little bit of work, this ends up being negative 21 and positive 10. So again, if this was just an a term, that would mean x equals 21, x equals negative 10. But again, we have to divide these by the a term, which is 6. So those are our answers, but if we can, we want to simplify. This one, top and bottom, are divisible by 3, so that's 7/2. And here, they're divisible by 2, so negative 5/3. And those are our answers. When we were looking at terms that had a leading coefficient of 1, typically I was giving you examples that we ended up with integers. If we're looking at a quadratic that has a leading coefficient that's not 1, most of the time you're going to end up with at least one fraction. Right? So in this first example, we had one integer, but the second term was a fraction. Here we ended up with two fractions. That's most likely going to be the case on these examples. And that's pretty much it for this section. One thing that you might want to keep a lookout for is if you have something, let's say it's 4x squared plus 24x plus 32. Right? Now, before I go and draw my x, you might recognize here that all of these are multiples of 4. So another strategy you can use in this section is that if there is a number you can factor out, you can do that. And that's because, just like in any other equation, right, you can sort of divide it out. As long as you do the same thing to the left and right side, the equation stays balanced. So if I divide everything by 4, 4 divided by 4, 24 divided by 4, 32 divided by 4, 0 divided by 4, that's still a valid question. And now it's just like 4.1. Those are easier numbers to have to work with. If your teacher asks you or instructor asks you to factor, then they're probably going to want to see that 4 factored out. But basically, we ignore it. Now I can do the x like before. A times c gives me 8. B is 6. Numbers that multiply to get 8 but add up to 6 are 4 and 2. So factor this is 4 times x plus 4 times x plus 2. Set each of those factors equal to 0, which means your solutions here are x equals -4 and x equals -2. That's all for today, guys. If you have any questions, please reach out to me. Otherwise, have a good day, and I'll talk to you soon.